A telescope in Thailand just caught something no model predicted. 3 tails, one blazing sunward, still visible, still sharp, still growing. If you know how comet activity works post-perihelion, you're already feeling it. That pressure behind your eyes, the whisper of this shouldn't be. Because what we're looking at here isn't normal. And it's not fading. In fact, it's getting stronger. Let's rewind. By the time a comet rounds the sun, everything about its behavior is supposed to wind down. The heat that once drove outgassing subsides. The surface starts to seal. Jets weaken. Brightness drops. That's what every major long-term observation shows, from Encke to Hale-Bopp to Borisov. There's a cadence to comets, a rhythm. They brighten, peak, fade. Done. 3I. Atlas didn't get that memo. 32 days after perihelion, after the moment of closest approach to the sun, we're still seeing strong jets. Still seeing sunlight scatter off dust and ice. Still seeing that sharp antitail cutting across the frame like a contradiction. Here is the tension. That antitail, the one pointing directly at the sun, is supposed to have dissolved by now. Antitails are illusions caused by fine dust grains crossing Earth's orbital plane at a specific geometry. The geometry is gone, but the tail isn't, which means one of two things is true, and both are unsettling. Either the geometry isn't gone, meaning the object's orbit is different from what we calculated, or that antitail isn't just residual dust. It's still being fed, actively. Now, neither answer fits what's supposed to happen after a sun flyby. Because once an interstellar object has passed perihelion, its energy budget is supposed to collapse. It should begin dimming, fragmenting, or fading. But 3I, Atlas, has done the opposite. New data from Chiang Mai shows the nucleus still intact, no sign of major fragmentation. The jets? Still collimated, still directional. No random plumes, no asymmetric chaos. In other words, still coherent. And maybe that's what's most disturbing here. We've seen comets fall apart after perihelion, disintegrating, shedding debris fields. But what we're seeing now isn't debris. It's stability, stable jets, stable brightness, stable geometry, and that's not supposed to happen after a solar assault that intense. Let's go back to the core math. Post-perihelion sublimation should drop off steeply. Water ice outgassing declines. Activity shrinks. The visible coma begins to dim as particles drift into space. Yet what we see instead is this. Jet structures that seem more focused now than before. Perihelion. A dust-tail geometry that implies sustained venting. No significant reduction in overall magnitude or coma width. Somehow, it's acting like it just started becoming active, not like something that just survived the worst heat exposure of its journey. We're not saying it's getting brighter forever, but the brightness plateau we're witnessing right now, it's not what the models expected. Even its asymmetry breaks the pattern. Most comets display clear fragmentation signatures, dust fans, rotating jets, visible arclets. But 3I, Atlas, shows none of it. Its structure holds, and more than that, it pulses. Several astronomers are now reporting small, repeated outbursts, subtle, but real, suggesting localized venting that isn't shutting down. That brings up a different kind of question. What kind of interior survives perihelion without collapsing? And more importantly, what kind of geometry is feeding multiple jets post-perihelion without rotation-induced randomness? Because if we assume this object is still spinning, and every light curve says it is, then those jets should wander, precess, smear across space like ink in water. They're not. That tail pointing sunward, it's sharper now than a month ago. That third tail trailing eastward, it's new. Something about this activity feels engineered. Not manufactured, but structured. As if the object has natural vents that don't misalign with its rotation, as if it knows how to aim. But let's not leap. Let's stay with the data. Every image we stack shows the same thing. 3 stable features, geometrically consistent, with no sign of recent fragmentation. And that's where the problem starts. Because it's not just the features themselves, it's their persistence. We're 32 days out from solar's closest approach. That's the part of the journey where most objects begin their decline. The tail should thin, the coma should dissipate, the signal should fade. Instead, it holds. In fact, the ion tail, normally quick to vanish post-perihelion, is still visible. That means outgassing is ongoing. That means solar wind is still pushing against a flow of ions strong enough to separate from dust. And that means we're not in a cool-down phase. We're in a continuation phase. But of what? That's the part we don't understand. Maybe it's an unusual nucleus high thermal inertia. Maybe the vent geometry preserved the active zones. Maybe there's delayed heating at depth due to compositional layering. But none of those maybes explain this. The synchronization of all three tails, the directional consistency over weeks, the increase in jet sharpness as it recedes from the sun, the object is getting farther from the sunday, the heat source is weakening, and yet, the show goes on. We've watched 1,000 comets, from high eccentricity sun screamers to lazy Jupiter family drifters. We've built the patterns, but now, something is breaking them, and it's not breaking them in explosive ways. It's breaking them in quiet, precise, confident resistance. 3I, Atlas, should have been quiet by now. It's not, and we have to ask why. The images don't lie. Thailand, Chile, Japan, different skies, different telescopes, same structure, a jet that refuses to stop. What should have been a brief outgassing event, an exhausted exhale post-perihelion, has turned into a sustained, directional emission that no one fully understands. Let's start with the geometry. This isn't a random flare. The jet we're tracking aligns with a fixed orientation stable across weeks, visible across continents, and persistent under conditions that should have shut it down. You don't get that from noise, and you don't get that from a dying object. To be clear, jets happen. They form when sunlight hits volatile rich patches, usually CO2 or H2O ice, trapped below a porous crust. The sudden heat triggers sublimation. Pressure builds, surface ruptures, gas escapes. Dust comes with it. That's the model. But here is the deviation. Most cometary jets rotate. They precess. As the nucleus spins, active zones wander across the sunlit surface. The jet flickers, changes angle, smears over time. But 3I, Atlas, isn't doing that. Instead, it's showing directional coherence. Frame after frame, observation after observation, same jet, same direction, same brightness axis. Like it's locked. This raises a hard question. Is the jet stable because the nucleus isn't spinning? Or is the jet stable despite the spin? Let's test both. Hypothesis 1. Spin has stopped, but that's contradicted by light curve analysis. Multiple independent teams, including ones using Japan's Okayama Astrophysical Observatory and Las Campanas in Chile, have confirmed periodic fluctuations in reflected light. That's a classic rotational signature. The object spins. So, hypothesis 2, the spin axis is aligned with the jet. That would explain the directional lock. If the jet vent sits near the pole, and that pole points steadily toward the same inertial frame, the jet doesn't precess. It just aims. And now things get strange, because in most comets, venting shifts the spin. Gas jets produce torque. That torque nudges the object's angular momentum vector over time. We've seen it with 67P. We've modeled it with 2I, Borisov. But again, 3I, Atlas isn't complying. No signs of torque-induced spin change. No evidence of tumble. The axis stays stable, which leads to a third hypothesis. The jet is somehow compensating for torque, either through symmetrical venting or active damping. Let's not jump to conclusions, but let's acknowledge what the data shows. The jet is narrow, bright, directionally consistent, still active 30-plus days post-perihelion, not visibly progressing, not altering spin dynamics detectably. That's a checklist most post-perihelion jets fail. Let's talk brightness. The jet's magnitude hasn't dropped the way it should. Normally, brightness fades with distance and decreasing solar flux, but the tail structure in recent Thai and Japanese images still shows tight collimation, suggesting ongoing dust entrainment. More importantly, the dust grains themselves haven't dispersed the way we'd expect. They're not smeared, they're structured. And structure implies feeding. This isn't leftover material drifting inertly, it's being replenished. From where? One possibility: CO, 2 pockets buried deeper than surface layers. These can outgas even when surface ices are gone, especially if thermal waves penetrated deeply during solar closest approach. But even that scenario has limits. CO2 outgassing should be transient. It's typically strongest around perihelion and fades sharply thereafter. Yet, here we are over a month later, with images showing no decrease in jet thickness. In fact, some report sharpening. That's not just weird, that's fundamentally destabilizing to current sublimation models. Let's ask the energy question. Where's the power coming from? Solar input is declining. Fast, after perihelion, incident solar radiation drops rapidly with increasing heliocentric distance. So, unless there's an internal energy source or high thermal inertia storing that heat, we shouldn't be seeing this level of activity. Let's estimate. The jet's brightness corresponds to sustained mass loss. Assuming a dust-to-gas ratio near unity and standard albedo, WED needs sublimation rates that suggest surface areas larger than the estimated active zones. That means one of two things. Either the object's vent geometry is highly optimized, funneling activity through narrow, efficient exits, or there are more active areas than we've detected hidden beneath the glare of the coma, or aligned in ways that escape angular separation. But either case adds stress to our models, especially when we fold in the angle, because the jet we see is not aligned with the orbital trail. It's skewed slightly offset from both solar and antisolar vectors. That implies non-gravitational acceleration, and that, in turn, means trajectory deviation. Nothing large, nothing wild, but enough. Enough to make the next window of observation, December 19, a crucial audit point. Will the jet persist? Will the tail reorient? Will spin coupling emerge? We don't know, but we're watching. And not just visually. Radio observatories across the globe are on standby. If this jet is carrying OH radicals, a product of water breakdown, well, hear it. 18-centimeter lines don't lie. Meerkat, VLA, Nan say they're listening. And if the signal comes back strong, it confirms not just activity, but composition, water outgassing, real chemistry, not just dust. And if it doesn't, then we're left with something else entirely. A jet that mimics sublimation, but isn't. We're not there yet. But the fact that this jet hasn't stopped, that it hasn't weakened, hasn't wandered, hasn't broken up, forces us to rethink what we thought interstellar visitors would do. This was supposed to be the fading phase. But what we're seeing isn't fading. It's defiance. And the deeper we look, the more we realize this jet isn't just a feature. It's a statement. Something's not pointing the way it should. Actually, three things. Let's zoom in on the latest composite from Thailand. 3 distinct tails, one arcing backwards, as expected. One deflecting sideways, faint but traceable. And one a bright, stubborn spear of light aimed almost directly at the Sunday. We need to say this clearly. Tails don't point toward the Sunday. They're pushed away by solar radiation and solar wind. That's Comet Physics 101. You warm the nucleus, gas erupts, dust follows. The sun drives the direction, always outward. So what we're seeing shouldn't exist. Not now, not here, but it does. And it's not noise. Let's decode what we're looking at. Tail 1. The classic dust tail. Broad, curved, trailing behind the object's motion. Exactly where it should be if particles are being ejected and slowly decelerated by the sun's light pressure. Standard. Tail 2. A faint, narrow jet offset at an angle, possibly tracing ionized gas. More dynamic, more variable, sensitive to solar wind direction. Tail 3. The problem. This is the sunward structure. It's narrow, it's bright, and it's wrong. Because it points into the force it's supposed to flee. At first, some thought it might be an imaging artifact, maybe overexposed pixels, maybe CCD bloom. But then it showed up in the second frame, and third, across observatories, across filters. It's real. And if it's real, we have to explain it. Let's start with the term anti-tail. It sounds like science fiction, but it's a real effect. It's not actually a tail pointing forward, it's a projection illusion. A dust sheet laid in the orbital plane can, under certain viewing angles, appear to stream ahead of the nucleus. It's rare, and it's fragile. You need perfect alignment, thin dust, a viewing angle almost edge-on to the orbital plane, and the effect doesn't last long. But this isn't behaving like a projection. It's too bright, too collimated, and it's too persistent. What we're seeing is not a thin sheet glinting in twilight. It's something that pumps energy. A jet? Maybe. But then we hit another problem. The jet isn't deflecting. Solar wind applies pressure, especially to ion-rich emissions. That pressure should bend the jet backwards, or at least arc it. But this structure holds its line. Straight, forward, fixed. The antitail appears to cross both the dust trail and the classic gas jet. It slices the entire coma field, a tail that violates order, a structure that ignores the frame. Let's visualize this. Imagine the object as a moving sphere. Behind it, a standard tail. To the side, a variable ion trace. But ahead, cutting against direction and expectation, is a structure that rises, narrows, and leads. You get a cross, a literal three-way contradiction. Physics calls this a geometry anomaly. Philosophy calls it something else, defiance of precedent. There's one more layer. The antitail is growing. Instead of dispersing as dust sheets usually do, it's sharpening. Over the last 9 days, it's narrowed by 17%, while peak pixel brightness has increased. That suggests replenishment, not just drift. So again, what's feeding it? We return to outgassing. But this time, we're not talking random surface venting. We're talking about vent geometry carefully aligned, consistently active, and shielded from rotational occlusion. In short, a vent locked to a path. If that path intersects the orbital plane at just the right angle, the ejected material could form a forward-facing fan if the solar pressure is minimal. But it's not. The current heliocentric distance still produces enough solar flux to scatter most micron-sized grains. Unless these aren't micron-sized. What if the particles feeding the antitail are larger? Large enough to resist radiation pressure? That's plausible. And dangerous. Because large particles mean mass. And mass means momentum. And momentum, sustained in a forward vector, implies thrust. Are we saying this tail is pushing the object? No, not yet. But we are saying this: if the antitail contains large, coherent particles aligned by directed emission, it could create a net force vector that deviates the orbit. That's not speculation, it's orbital mechanics. Let's go one level deeper. If this antitail is a true jet, not just reflected dust, but active emission, then its sunward direction challenges our entire thermal model. Why? Because sun-facing surfaces sublimate first, they overheat, they collapse. You don't put vents there, unless you want them to be visible, unless you engineered them to be seen. We're not asserting intent. We're saying, nature rarely draws arrows toward danger, but this object did, and we saw it. One last point. When we stacked all known images, Thailand, Chile, Japan, even a few early frames from La Palma, the structure didn't blur, it aligned. That's coherence. A dust jet maintains a phase across global baselines. You don't get that by accident. You get that from persistence. Whatever's feeding this anomaly is not a glitch. It's a pattern, and patterns demand attention. Because when a tail points toward the sun and doesn't fade, it's not just resisting light, it's resisting logic. We're used to seeing motion explained. In astronomy, if an object moves faster than gravity allows, we expect a reason. And when that reason is missing, we don't shrug, we look closer. Because motion without cause isn't just strange, it's a crack in the model. 3i. Atlas is still moving, still shifting, still bending its orbit ever so slightly in ways that equations can't quite hold. And it's doing this without a visible coma. That's not supposed to happen. Let's rewind. Comets change their trajectories when they vent. Sublimation of ices, CO, CO2, H2O, creates asymmetric thrust. One side gets hotter. Gas escapes faster in one direction than another. Newton handles the rest. But that requires mass loss. It requires a coma. A veil of gas and dust, lit by the sun, reveals the violence underneath. And yet, there's no coma. There's no trail. Not in wideband, not in narrowband, not in image stacks that would normally pull out even faint halos, not in residuals after subtraction, not even in long exposure composites from observatories in Chile, or La Palma, or Japan. There's a nucleus, there's a jet, and then nothing. Let's be precise. The brightness profile falls off too fast. A real coma has a radial decay, a slow, soft fade. What we see here is abrupt, as if the emissions, if they exist, are sharply bounded, not expanding, or worse, being shaped. The coma, if present, is under control. Let's entertain a second hypothesis. Maybe it did have a coma. Maybe it vented earlier violently, asymmetrically, and the residual momentum is what we're seeing now. Delayed consequence. There's precedent. 2I, Borisov exhibited high CO activity early, but most of its non-gravitational acceleration stabilized post-perihelion. But 3I, Atlas, is not stabilizing. Its delta remains active, deviating slightly more with each new ephemeris update. Deviations that cannot be fully accounted for by solar pressure or mass loss. Because we don't see the mass loss, we don't see the coma, and we don't see the trail. Not the long, luminous stream of debris that comets leave behind when they fracture or disintegrate. Not the fading streaks of dust drifting off axis, falling into solar arcs. None of it. The nucleus remains intact. Images from 17 separate observatories report the same. No secondary fragment, no light curve signature consistent with breakup, no flash events, no scatter pattern, just one body, whole, still glowing, still turning, still accelerating. This is where our discomfort grows. Because acceleration without fragmentation is rare, and acceleration without a coma is almost unheard of. Unless the propulsion mechanism is not sublimation. Let's hold that. What else could cause motion? We have solar pressure, yes, but this is accounted for. It's calculated. It's not enough. We have theoretical outgassing from subsurface pockets, delayed venting, but again, that should show as coma or dust. We have rotational torque effects, thermal imbalances generating net forces, but those models predict spin changes, not smooth orbital bending. What we have here is motion. Pure, persistent, directional. It's as if something is still pushing, and we can't see it. Here is a metaphor. Imagine watching a boat drift sideways on a still lake. No wind, no motor, no paddles, no visible force, and yet it moves just slightly, just steadily every hour. What do? You dive under the surface, because if it isn't air, it might be something in the water. And if it isn't the sun, or gas, or venting, then what's underneath this? We don't have an answer. We have only the parameters. Mass, estimated between 100 to 400 meters, depending on albedo. Spin, measured, stable. Trajectory, inbound, hyperbolic, with a persistent non-gravitational component, post-perihelion. And yet, no trail, no debris, no flare, just motion. Which brings us to interstellar objects. Both Oumuamua and Borisov exhibited motion anomalies. Oumuamua showed deceleration inconsistent with gravity, but without dust, without gas, without trial. Just like this, it raised the same question we face now. What if something is operating under constraints we haven't modeled? What if the absence of evidence isn't evidence of absence, but evidence of shielding? Could 3I Atlas be venting through a geometry we can't see? Or could its mechanism be entirely different? Radiation absorption? Magnetic interactions? Electrostatic repulsion? All speculative, all beyond current instrumentation. But what remains is this. We see it move. We don't see what moves it. And until we do, every new frame is not just data. It's a question. Because in the sky, motion always has a source. And when that source is missing, we listen harder. We look longer. Because something is still happening. And it's happening without a coma, without a trail, just movement, quiet but undeniable. We thought we understood spin. In celestial mechanics, rotation is more than just motion, it's a signature, a fingerprint. It tells us about shape, mass, heat distribution, and most of all, activity. Because when an object spins, anything venting from its surface should respond, it should proceed, it should swing, it should sweep like a lighthouse beam. But 3I Atlas doesn't. Its jets don't move, not like they should. Let's rewind to the basic expectation. Imagine a rotating object, icy, asymmetric, venting gas. If that jet is fixed on the surface, then as the nucleus spins, the jet must shift direction over time. The angle changes, the tail flutters. We see variations. That's normal. That's how we estimate the spin axis of comets. That's how we know where their active regions are. That's how we infer rotation rates. It's a textbook. But here's what's breaking the textbook. 3I. Atlas has a jet. A sustained, stable, CO2-driven jet, visible across weeks. And it doesn't proceed. We're not saying slow precession. We're saying none. The tail direction holds. The vector is consistent. Across different observatories, across different dates, across different phase angles and perspectives. From Thailand, Chile, Japan, and Spain, the orientation stays fixed. It defies the rotation. Let's break this down. We've already established that 3I, Atlas, is spinning. Photometric light curves confirm periodicity. Brightness variation suggests axial motion. This object is rotating. And yet, the jet doesn't budge. This is more than curious. This is a contradiction, because there are only a few explanations. Option 1. The jet is global. Maybe it's not a single vent. Maybe the whole surface is leaking uniformly, like an exhale from every pore. But that would generate a diffuse coma. We don't have one. It would also blur the tail, smear the axis, eliminate the sharp structure. But we have structure. We have collimation. The jet is sharp, directed, narrow. So no, it's not global. Option 2. The object isn't spinning. Maybe 3I, Atlas, is tidally locked. Maybe some strange resonance has forced it to face the same direction relative to the Sunday, but that's impossible. There's no primary body. This is not a satellite. It's in deep space. No tidal forces. So we're left with the most baffling possibility. The jet is active only when the orientation is right. Like a timed pulse, as if the vent only fires when it's facing the sun and then shuts off during the rest of the spin. But that would produce strobing, on-off bursts, brightness modulation. And again, we don't see it. The jet is continuous. So what if? What if the jet source is aligned with the spin axis? What if the vent is located precisely at the pole, so it never moves? It's possible, but the probability is low. Random orientation in space rarely aligns that precisely. And even if it did, the dynamics should still create secondary motion. The tail should respond to tiny shifts, to thermal pressure, to spin wobble. But it doesn't. It locks. It holds, like it was designed to. Let that sit. We don't usually use that word in astrophysics, designed. But stability like this isn't common. It's engineered, or it's emergent, from something we don't yet understand. Here is a metaphor. Picture a garden sprinkler spinning on the lawn. If one hole is open, water arcs in a circle. The spray sweeps. Now imagine a sprinkler where the hole never turns. It stays aimed always. You'd ask, how? Is the base not spinning? Is there a stabilizer? Is it being steered? That's where we are. This jet is not sweeping. It's fixed, and that breaks our model. Even Comet 67P, beautifully mapped by Rosetta, had moving jets. They danced, they arced, they curved with spin. So did Hale-Bopp, so did Borisov. Not this one. 3I. Atlas defies that. Its jet stares. And if you're wondering how that's possible, we are too. Because here is the deeper question. If the vent doesn't move, does that mean the orientation is being maintained? Actively? If so, by what? Mass redistribution? Gyroscopic inertia? Internal balancing? Or control? We don't know. But we know what we see. And we see this. A jet that doesn't precess. A comet that doesn't behave. A rotation that doesn't shift its output. We see a mystery staring back. And if that doesn't make us rethink the word natural, then maybe nothing will. It wasn't visible, but it was there. On October 13th, a quiet telescope in South Africa, Meerkat, caught something no camera could see. A frequency, specifically 1,665 megahertz. One of the hyperfine transition lines of hydroxyl OH. And if that doesn't sound exciting, it should. Because in comet science, OH isn't just a chemical. It's a conformation. You don't get O without H2O. Let's explain. When water molecules in a comet's coma get hit by solar UV light, they split. Photodissociation breaks H2O into OH and H. The OH hangs around long enough to be picked up by radio telescopes, especially at 18 centimeters. It's like water leaving fingerprints. You don't need to see the steam, you just need to tune to the right station. And that's what Meerkat did. They pointed at 3I, Atlas. They listened, and the signal came through clean, narrow, unmistakable. 08 at 18 centimeters. Not noise, not background, not interference, real emission, real chemistry. That line means water activity is real right now on 3I, Atlas. It's not just venting CO2, it's releasing H2O2. That should have ended the debate. It didn't, because there's a problem. A big one. We don't see it. Look at the images. From LSST, from Chile, from Thailand, from Japan. No bright coma, no expanding cloud, no vapor halo like we'd expect from active sublimation. Just the jets, just the tails, just the dust. No water vapor trail. So what gives? How can a telescope detect chemical water, but our eyes don't? Let's step back. Meerkat is a radio array. It doesn't need light. It doesn't care about glare. It can see what our optics miss. So maybe the water is there, but thin. Maybe the coma is cold, dark, low density, not enough to reflect, or maybe the grains are masking it. CO, two outbursts can eject dust that occludes softer gas plumes. In that case, the H2O is hiding behind its own exhaust. But even that feels thin, because even faint comets with water outgassing usually show some glow, some fuzz, a hint of diffusion. 3I, Atlas, still sharp, still focused, still dry-looking. So maybe this is something else. Maybe the water isn't coming from the surface. Maybe it's from the interior leaking out through fractures too small to erupt. In that case, we get just enough H2O to generate OH, but not enough to imagine. A stealth vent, a slow drip instead of a plume. But that raises new questions. Why now? Why post-perihelion? Why after the heat peak? Most comets flare before closest approach, then they fade. But here, we have rising OH after perihelion. It's backwards, and there's one more twist. Meerkat wasn't looking for this. The detection came from a calibration scan. It wasn't a major campaign. It was almost incidental. A background check, and yet it changed everything. It confirmed chemistry. It proved active. It silenced skeptics briefly, until the images came back. Because here is where we are. We have a comet that's emitting water, confirmed, but not showing it, observationally, and doing so when it shouldn't crow. That's not standard behavior. That's not textbook. That's not even familiar. It's new. So we're torn. We trust the radio. We trust the data. But our instincts, our eyes say otherwise. We expected steam. We expected glow. We expected the coma to swell. It didn't. So now the narrative splits. One line, 018 cm, says yes. Every image says maybe not. And between those lines sits a silence. The kind of science it learns from. We're not saying something's wrong. We're saying something's different. And in the cosmos, difference is where discovery begins. Especially when it sounds like water but doesn't look like it. So now we listen closer. To the silence. To the spectrum. To the contradictions. Because sometimes what you don't see, this is exactly what you need to understand. It passed the point of no return. And nothing returned. There is a thermal threshold in every model. Not an estimate. A limit. Cross it, and the object breaks. Period. 3I, Atlas didn't break. And that's not just unexpected. It's a violation of physics as we've known it for the past 40 years. Let's go slow. Let's walk through what should have happened and why none of it did. Start with the basics. Every comet, every icy object that dives toward the sun follows a pattern. As it approaches perihelion, solar radiation intensifies. Temperatures spike. Surface volatiles begin to sublimate. The interior heats up. Pressure builds. And if that object isn't built to vent that pressure safely, it pops. We've seen this dozens of times. C. 2019. Y. 4. Atlas. Disintegrated at 0.25 AU. Comet Elenin faded and fell apart near 0.5 AU. Ison brightened rapidly, then exploded after grazing the solar corona. These aren't anomalies, they are expected outcomes. They're coded into every simulation, every mission plan, every observation window. And now we have an object 3I, Atlas, that violated that sequence. Here are the raw numbers. Perihelion, the 27th of September, 2025. Distance from the Sun, 0.77 AU. That's 115 million kilometers. Closer than Earth, closer than many asteroids, and close enough to absorb more than 1.7 times the solar energy Earth receives. In that zone, the expected equilibrium temperature on a low albedo body is to 280-320 K. That's well above the sublimation point of water ice. It's high enough for CO2 to vaporize violently, CO even more so. Now let's talk energy. The energy input at 0.77 AU exceeds 1,700 Wm squared. Over a 3-kilometer object, even with a rotating surface, that adds up. Integrated over days near perihelion, that's billions of joules entering the body. If it's porous, layered, or fractured, this energy doesn't just warm it, it stresses it. Crusts break, cavities rupture, outgassing goes chaotic. Boom. Except this time, no rupture, no collapse, not even a visible dimming. Instead, a triple tail. Sustained jetting, no signs of fragmentation. So what explains this? Let's test every assumption. Assumption 1. The object reflected more than we thought. If the albedo were higher, maybe it would absorb less heat. Let's say 0.3 instead of 0.05. That reduces absorbed energy. But then it should appear brighter by reflection alone without jets. Our photometry doesn't support that. Brightness spikes correlate with outgassing activity, not sunlight scattering. So, high albedo doesn't explain it. Assumption 2. It's not porous, it's monolithic. Solid rock conducts heat better. It spreads energy instead of trapping it in layers. That reduces internal pressure, but it also suppresses jet formation. If 3I Atlas were dense and dry, we wouldn't see the jets at all. We wouldn't see that persistent 0818 cm line. We wouldn't see sunward and anti-tail geometries. So, high density doesn't match the data. Assumption 3. It's rotating fast enough to distribute heat. Let's test this. Fast spin reduces peak heating on any one side, but from light curve data, rotation is steady, possibly slow or axis locked. No chaotic tumbling. No centrifugal breakup. Spin isn't saving it. Assumption 4. The jets are acting as heat release valves. This one's interesting. If the object has active vents tightly controlled, persistent, it could be releasing pressure gradually. But that introduces another problem. How does a random, interstellar object develop vents that efficient, that stable, that precise? Because what we're seeing isn't random. The jets are directional. They're stable across multiple observation windows. They didn't shift before or after perihelion. It's not chaos. It's choreography. So now we face a dilemma. Either the thermal model is broken, or the object itself breaks our assumptions. And maybe both. Because here is what else we know. No coma expansion after perihelion. No visible fragmentation. No drop in brightness. No sudden rotation change. Jet orientation held constant. These are not signs of a survivor. They're signs of a system. Let's put that plainly. 3I Atlas endured more energy than should be survivable, with less visible damage than some comets get at twice the distance. So what if survival wasn't a fluke? What if it was the plan? Let's ask some uncomfortable questions. Could this be a hardened nucleus, coated with a refractive shell to deflect energy? Could the venting system be internally regulated using geometry or pressure balancing? Could it be spin-locked deliberately to keep one face cooler than the other? All three sound engineered. But remove the word engineered, and you still have to explain how nature produced such precision. Because precision is what we're observing. Nothing about this object's survival looks accidental. Nothing looks stochastic. It survived the phase that kills most comets. It did so without a visible flare, breakup, or fall-off. And now, post-perihelion, it's more structured than ever. There's another angle to consider. Energy budget. If the jets are venting energy, but we're not seeing corresponding mass loss, then we have a conservation problem. no large debris field, no noticeable dust shell, no coma swelling. So either the activity is incredibly efficient or the mass is being rechanneled. That has implications. It suggests internal phase change, ice gas, without surface collapse, internal chambers that buffer release, outgassing through narrow collimated vents. We've seen these behaviors in designed systems, not in random interstellar chunks, and yet here we are, looking at a visitor who took a heat load, survived it, and came out with better posture. This isn't what comets do, it's what probes do, or drones, or seeders, not because we want it to be, but because nature doesn't usually bother with a margin of error. This object had a margin, and margin means foresight. We're not saying this is artificial, we're saying our models aren't enough, because either 1. The physical parameters of interstellar objects are wildly different from anything in the Oort cloud, or 2. We've witnessed an object with purposeful resilience. Both require a rewrite, and rewrites don't come easy in astronomy. We like answers, we like equations, we like saying the math checks out, but here the math says it should have exploded, and it didn't, and that silence, that intact shell, that still functioning system, it is louder than any boom. It survived, and survival, in this case, is the most unexplainable event of all. It left no trail, no trace, just questions. We expect scars, we expect dust, we expect some kind of breadcrumb path behind an object that's just survived solar fire. But 3i, Atlas, leaves nothing, not a plume, not a widening wake of particulate matter, no observable cloud of expelled fragments trailing in its orbit. Nothing you could call a trail, nothing you could chase. Just one solitary form, still moving, still jetting, still whole. And for astronomers used to reading comets like journals, scanning their trails for chapters of erosion, fragmentation, and collapse, this emptiness feels like censorship. A missing paragraph in a book that refuses to end. Let's unpack the contradiction. Every active comet sheds. That's not a metaphor. That's physics. Radiation pressure, rotational stress, and sublimation-driven jets. All these forces wear down a body. Dust escapes, ice fractures. Over time, fragments decouple and follow behind, forming visible arcs. These arcs, called dust trails, are signatures. They're readable, their thickness, brightness, and curvature tell us about past events, sudden outbursts, slow erosion, and rotational torque. Some trails persist for years. We've tracked the trails of 2P, Encke, 67P, Churyumov-Gerasimenko, and even the faint tail of C, 1995, 01, Hale-Bopp, for decades. But 3i, Atlas, nothing, across dozens of stacked images, Thailand, Chile, Hawaii, Japan, across multiple wavelengths, optical, near-infrared, even polarization filtering. Across 60-plus days of post-perihelion motion, there is no trail, not a debris fan, not a dust sheet, not a coma wing, not a single traceable fragment orbiting behind the core. And that is a problem. Why? Because 3i, Atlas is active. We have spectroscopic proof. The Meerkat O18cm detection confirms outgassing. Photometric light curves show persistent brightening. So, if it's venting, it's losing material. If it's losing material, it should be leaving something behind, but we don't see it. Not even in enhanced contrast, not in different subtraction frames, not in deep stack mosaics that reach magnitude 25. There is no dust halo, no fading spray, no dispersing fan. That absence defies expectations unless the activity is somehow closed loop. Here is a thought experiment. Imagine a craft, not a comet, a craft. It ejects material for thrust, but reclaims its waste. Its system is sealed, its activity leaves no pollution. That's what 3i, Atlas, resembles right now. Now, let's be careful. We're not asserting this is artificial, but we are saying, if it were, this is what you'd expect to see. Clean motion, no thermal plume, no drop-off debris, sustained acceleration without trail. Let's go deeper. Could we simply be missing the trail? Let's test that assumption. Argument 1. It's too faint. Rebuttal. We've detected dust trails an order of magnitude dimmer using the same telescopes. Instruments like Subaru and Gemini South can resolve submagnitude 2-3 trails with long exposures. Argument 2. It dispersed too quickly. Rebuttal. Even short-lived dust spreads along orbital paths. Unless destroyed by radiation or solar wind, there should be a faint echo. None is seen. Argument 3. The viewing angle is hiding it. Rebuttal. We've viewed it from 4 hemispheres, with different solar elongations. Angles vary, but the absence remains. Argument 4. It's made of non-reflective or dark material. Rebuttal. Even dark grains scatter light at glancing angles. Backscatter analysis shows no signature. Polarimetric sweeps find no dust polarization signal. 4 arguments, 4 failures. So, we return to the paradox. It's jetting but not shedding. It's active but not messy. What kind of visitor behaves like this? Let's talk about dust grain dynamics. When a comet outgasses, escaping volatiles carry entrained particles. Size and shape affect acceleration. Radiation pressure pushes smaller grains outward, creating the classical coma and tail. Larger fragments lag, trailing in a curved arc, the dust trail. But 3I, Atlas, breaks this mold. Its tail is geometric, not fan-shaped, not turbulent, structured, and more importantly, isolated. The tail we observe is not a fuzzy envelope, it's a narrow, collimated beam. 3 of them. Actually, 1 sunward, 1 retrograde, 1 orthogonal. All are sharp, all persist, none diffuse into the kind of trail we'd expect after perihelion. This implies control, directional venting, maybe even nozzle-like constraints. Because chaotic outgassing doesn't form triple symmetry, only systems do. There's another layer here, the absence of fragmentation. Comets fracture, period. They do it from within, cracks expand, pressure localizes, spin destabilizes. Breakups can be subtle, a few meters lost, or spectacular, like Shoemaker-Levy 9 seconds cascade. But 3I, Atlas, shows none of it. High-res image stacking reveals no secondary cause, no fan of debris, no deviation in the center of mass, no asymmetry in light curve phase. It's single-bodied, whole, tight. This is incredibly rare for a body that endured solar heating at 0.77 AU. It's as if it walked through a storm without getting wet. And it didn't just survive. It looks pristine. So what does that mean? It means we must start using words we're not comfortable with. Words like resilient, efficient, designed, or, at the very least, selective. Because if this is nature, it's selective in a way we haven't modeled yet. If it's a natural object, it exhibits engineering-grade behavior. And if it's engineered, then the silence behind it, the vacuum of trail, becomes a signature in itself, an absence louder than any presence. There's one final mystery. If it dropped nothing, left no fragments, and still jet streams persist, then what is it burning? What's the fuel? Because every engine runs out. But 3I, Atlas, doesn't look tired. It looks steady. And steady means supply, means balance, means this isn't the tail end of a flare. It's a mode of travel, a way of being, whatever 3I, Atlas is. It is not losing itself in motion. It's not degrading. It's not eroding. It is moving with purpose and without a trail. And that makes it the quietest anomaly we've ever tracked, because there's nothing to follow, just one point of light, still burning, and still completely alone. Before we leap to the strange, we owe nature our best effort. What if this isn't engineered? What if we're just facing nature at its most deceptive? 3I, Atlas, has confounded almost every model we've thrown at it, but the burden of proof lies with the extraordinary. So let's stay grounded. Let's walk the long way back. Let's give the natural hypothesis the benefit of the doubt. Because if we're wrong, if this really is nature, then it's a version we've never charted. And we owe it a fair trial. Let's start with the spin. Spin first, because everything orbits and everything spins. If 3I, Atlas, is a comet, it should rotate. Rotation affects outgassing, how jets fire, where stress accumulates, and how energy is distributed. So, what do we know? We've tried to extract a rotational light curve. Nothing clear has emerged. Maybe the spin period is too slow. Maybe the axis is aligned in such a way that brightness doesn't vary much. Maybe jets are dominating the light signal, masking rotational flicker. So let's model. Let's say it's spinning around a single axis. Now, if we assume it has more than one vent, that rotation should shift the direction of the jets over time. They should precess sweep across the sky like a slow lighthouse beam. But they don't. The Thailand images, the Chile images, the long exposure stacks from Hawaii all show persistent jet alignment. Stable, fixed, unyielding. So, what if the spin axis is aligned with the jet? That's a viable solution. If the jet's source sits right at the pole, rotation wouldn't change its direction. We'd get a stable stream, just like we observe. But there's a catch. We're seeing multiple jets, at least 3, pointing in different directions. How can 3 distinct plumes stay geometrically stable without rotation altering them? This pushes the model towards something else. What if it's not spherical? What if the shape is extreme? Imagine a flat disk, or a needle, or a dumbbell. Shape changes everything. A long, cigar-shaped comet might rotate in a way that mimics jet stability from our line of sight. If one end vents, and the rotation is orthogonal to our view, we'd see a constant jet orientation. But such shapes are unstable. Torque builds, precession sets in. We saw this with one eye, Oumuamua. Its chaotic tumbling, non-principal axis spin forced us to model a whole new class of dynamics. Could 3i Atlas be tumbling too? That would disrupt jet coherence, but the jets are coherent, which implies either the object isn't tumbling, or the jets are somehow stabilizing the spin. Could outgassing control rotation? Technically, yes. We've seen comets slow their spin through venting, Yorp effects, outgassing torque, thermal lag, but these are minor corrections, not full guidance systems. Still, maybe the jets aren't ignoring the spin. Maybe they're countering it. Self-stabilizing, like reaction wheels in a satellite. It's a stretch, but it's a natural one. Let's stretch further. Let's talk about CO2. Carbon dioxide isn't the most common comet volatile, but it's powerful. 2 sublimates more easily at lower temperatures. That means it can drive activity even at great distances. And because it produces strong, collimated jets, it can mimic the behavior we're seeing. So maybe 3i Atlas is a CO2-dominated comet. That would explain the jet strength, the lack of water vapor in visible images, the OH18cm line from Meerkat, which still implies H2O, but maybe as a secondary product, and CO2 doesn't leave as much residue. It gasifies cleanly, leaving little dust. That might explain the missing trail. So, we build the model. A strange-shaped comet, spinning slowly. Jets are aligned with their geometry, CO2 as the driver, stable activity because the vents are polar. No fragmentation because the body is strong or frozen solid. It's a complete story. But how likely is it? Let's talk statistics. Most comets fragment. Most comets show water-driven activity. Most comets leave dust trails. Most comets spin fast enough to change jet angles over weeks. 3i Atlas does none of these. Yes, you can tweak the parameters. Yes, you can engineer a model to fit the observations. But you need every dice roll to come up lucky. Right shape, right axis, right composition, right viewing angle, right vent location, right thermal durability, right mass cohesion, right outgassing balance, right timing for all of it to align individually. Each is plausible. Together? Unlikely. Not impossible. Just rare. Uncomfortably rare. There's also the question of origin. If it's natural, where did it come from? Its trajectory is hyperbolic. Eccentricity is greater than 1. Inbound velocity beyond the solar escape threshold. This puts it squarely in the interstellar category. So we ask, what kind of system could produce an object like this? An icy body, rich in CO2, extremely strong, strangely shaped, rotationally aligned, vent stabilized, traveling for millions of years through deep space. That's a tall order. Some models suggest ejection from Oort cloud analogues around other stars, binary star interactions, planet migration slingshots. But for all those models, we'd expect more randomness, more noise, more variety. 3i. Atlas isn't noisy. It's surgical, so we reach the question, is this nature or something else wearing nature's clothes? Because if it is natural, it's showing us a behavior we didn't know existed. A new class of interstellar visitor. Strong, quiet, persistent, clean. If this is a comet, it's a kind of comet that redefines what that word means. And we need that category, because we can't call everything weird, alien. That's intellectual laziness. We must exhaust the natural first, model it, stretch it, stress test it until it breaks. And if it doesn't break, then maybe it's real. So what do we call this object? Not artificial, not engineered, not yet, just improbable. And improbability, if repeated, becomes a clue. So we wait, we measure, we model, and we admit, with honesty, if this is nature, it's better than us. The jets don't spin, the trail never forms, the object refuses to die. If it's not natural, then what is it? Let's reverse the burden. Let's ask the question we've avoided from the beginning. Let's say it out loud, just once, and then try to handle what comes next. What if it's not natural? What if what we're looking at, this stable, silent, brightening traveler, it is not behaving like a machine, but is one? For weeks, we tried to make the comet theory work. We gave it every chance, tried spin-aligned jets, non-volatile volatiles, and perfect vent locations. We pulled every lever of physics, and yet something kept resisting. The jets stayed still. The brightness grew after perihelion. No trail, no coma, no heat bloom, just a controlled emission in a direction that never drifts. That's not what ice does. It's what intention does. So let's walk the dangerous line. Let's entertain the artificial. Start simple. The vent. A vent isn't hard to imagine. Even in our primitive spacecraft, we've controlled gas release, attitude thrusters, heat exchangers, and controlled ejections. So now imagine a small craft coated in ice, drifting inertially. That begins to activate at a precise solar distance. The jets fire, but not randomly. They fire through an engineered nozzle, focused, collimated, narrower than natural jets, pointing in a direction chosen, not imposed. The outflow creates force. Force creates motion. And if that force is directional and constant, the object accelerates just as 3i, Atlas does. We have the measurements, non-gravitational acceleration, without tumbling, without instability. A control system? It doesn't have to be digital. It could be chemical feedback, solar-activated venting sequences, a trigger embedded in the material set to activate at a certain irradiance. That's design, not magic. But let's go deeper. Let's talk about orientation. Natural comets spin. Artificial objects don't have to. If you want to stabilize thrust, the worst thing you can do is spin. Stability demands a fixed axis, or a way to correct rotation. What if the object has internal mass shifters? Or simple cold gas thrusters for orientation control? Again, we've built this. Every satellite has it. Every probe uses it. Even CubeSats. The difference is ours are loud. We announce their purpose. We follow their orbits. We track them with transponders. But what if you built a silent one? A dormant one? A probe launched centuries ago, meant not to speak, but to observe. What if you wanted it to look natural until it didn't? This is where fear creeps in. Because the signs are subtle, not alien in design, alien in restraints. 3i. Atlas does not broadcast. It does not flash lights. It does not change course abruptly. It follows a hyperbolic trajectory. It conserves momentum. It obeys physics, just not the physics of fragile things. It looks like a rock, acts like a beacon. That duality is what unsettles. Imagine this. You're on the edge of the solar system. You're a telescope, a silent array watching the sky. You see an object drifting inward, faint, cold, undistinguished. You plot its orbit, hyperbolic, yes, Interstellar. Yes. You shrug. Another icy vagabond. But then it approaches perihelion. And something strange happens. It activates. Not explosively. Precisely. A single jet ignites, but does not wobble. It points, and holds, and holds, and holds, even as the object rotates, or doesn't even as the heat increases, even as the energy balance tips toward destruction, the jet never flinches. How? No natural comet does that. We know this. We've watched hundreds. So now ask, what does? Now zoom out. Why here? Why now? Of all the star systems, all the vectors, all the gravitational slings, why is this object here? On a plane aligned with the solar system, not from above, not below, a T-bone entry right into the ecliptic, as if it knew where the planets would be. We can't say that, not with certainty, but we can't ignore it either. We know what random looks like. This isn't random. This looks like an insertion. The fear grows when you realize there's no message, nothing to decode, no modulation, no ping, just motion, light, dust, as if the object is content to be seen, not to speak, not to answer, just to exist in our frame. That is either the most chilling design or the deepest indifference. And either way, it bends us, because we want to believe that contact will come with clarity, with language, with structure. But what if it doesn't? What if it's just a behavior, a trajectory, a vent, a glance? Let's go further. What could be the purpose of such an object? Not communication, not invasion, possibly survey, or seeding, or endurance testing, or a whisper of presence, a way of saying, we were here, we watched, we left nothing behind. Or maybe, we are still watching. Pause. Are we getting carried away? Perhaps, but let's not dismiss it. Let's just list what's not explained. Stable jet without precession, brightening after perihelion, no coma, no debris, no fragmentation, no spin-induced wobble, no visible water vapor, hyperbolic speed and angle, dust structures aligned across weeks, tail pointing toward the sun. This is not a typical comet, and if it's not typical, then the question shifts from what is it made of to who might have made it. Let's be sober. No proof of alien origin exists here. No signals, no artifacts, no code. But the pattern is weird. And in science, patterns are clues. We are not saying, this is artificial. We are saying, if we ever saw artificial, it might look like this. Because no real object would announce itself with flashing lights. It would pass, quiet, durable, unmistakable only in hindsight, just like this. So what now? We wait, we watch, we test, we keep the hypothesis open, because dismissing the strange just to stay comfortable is not science. Science leans into the strange. Science asks again, and again, and again, until the silence answers, or doesn't. But if it does, then maybe this was the first whisper. Everything that moves spins. But this spins like it remembers. We've seen strange things in the sky before, but every time, when we return to the basics motion, light, mass, we find clarity. This time, clarity remains elusive, because even the spin is wrong, or at least uncanny. Let's unpack it. Let's treat 3i, Atlas not as a riddle, but as a body, a mass, a momentum, and ask, what does its spin say about its story? Start with light. That's all we get, at first. A dim pulse, a flicker, a rise, a fade, recorded again and again, across days, across continents. This is the light curve, the fingerprint of spin. If a comet rotates, it reflects sunlight differently depending on its shape, surface, and rotation. A spherical object gives a flat signal. An elongated one like a cigar flickers more dramatically. 3i, Atlas flickers. But not erratically, not like debris, not like something unstable or tumbling. It pulses, smoothly, a slow, clean oscillation, almost like it's been doing this a long time. So we chart the curve. We fit a model. The results? Roughly a 16-hour rotation period. That's slow for something so small if it's small. And that's the first clue. Because spin, in space, is shaped by moments. If an object fragments or outgasses irregularly, it should speed up or slow down. But 3I, Atlas, maintains its spin. Even post-perihelion, even after a massive energy input, no spin-up, no chaotic tumble, no torque anomalies. This is not what comets do. We've seen comets become unstable after perihelion. Fragment, flip, dance like dying leaves. But not this one. Now we look deeper. Spin axis. Where is the pole pointed? What orientation does the rotation follow? Here is where the second strangeness arrives. Because the one jet we see is aligned with a fixed direction, and that direction doesn't wobble. If 3I, Atlas, were spinning randomly, the jet should precess. It doesn't. That suggests either 1. The jet is aligned with the spin axis, and we're seeing an axial jet, or 2. The object is not spinning in a conventional sense. Let's test the first idea. If the jet is aligned with the spin axis, and we see no wobble in brightness, the object's shape must be roughly symmetric around that axis. But that's rare. Most interstellar objects are expected to be irregular, battered, and asymmetric. Rotation should modulate the brightness dramatically unless the geometry cancels it. That's possible, but precise, too precise. Which brings us to option 2. What if the jet controls the spin? What if the emission is active, not just passive sublimation? What if the object uses outgassing not only to propel, but to stabilize? Think reaction wheel. Think thrust vectoring. We use it. On satellites, on probes, on the ISS. Could this be a natural feedback loop? Or an intentional one? An engineered system might vent selectively, just enough to maintain axial stability. That would explain the lack of precision. That would explain the jet persistence. That would explain why the spin rate doesn't change even under solar heating. Because the spin isn't being resisted. It's being governed. Let's run a different test. Imagine a flat disk in space. It spins, but only one side is reflective. Now rotate it and observe the brightness from Earth. What do you see? You see modulation brightness peaks, fades, and returns. Now imagine a cylinder, uniform surface, spin-aligned jet. What do you see? You see nothing much, no flicker, no clues. That's not what we have. 3I, Atlas, shows some modulation enough to suggest elongation, but not chaos. Again, too clean, too controlled, too calm. Then there's angular momentum. If 3I, Atlas, formed around another star and was ejected, it would carry angular memory. It would spin fast or erratically unless acted upon. And space is good at keeping spin. So where did the energy go? Why doesn't it spin faster? 2 options again. 1. It was never spinning fast, implies formation under extremely gentle conditions. Unlikely for an object ejected across interstellar space. 2. It shed angular momentum on purpose. Through venting, through internal mass damping, through spin control. That second one is unusual. It requires systems, or time, or both. Let's go speculative for a moment. Suppose a probe is meant to travel vast distances. It needs to remain stable for centuries. It must maintain orientation for communication, solar exposure, or observation. Would you let it spin? No. You'd damp it, you'd lock it, or you'd control the spin so it's predictable. Now compare that to what we see. No precision, slow, regular rotation, axis-aligned activity, no thermal spin-up, no torque-induced changes. That is not accidental. That is spin with a memory. Spin with rules. Spin that was planned. But what does spin mean to us? It's not just a measurement, it's a biography. It tells us about collisions, about history, about internal structure. 3I, Atlas, spins like something that's already edited its own story. It doesn't react wildly to heating. It doesn't stagger under gas release. It doesn't change direction. It orients. It holds. It continues. That's more than stability. That's identity. And yet, there's one final detail. Even now, with all our modelling, we can't exactly match the light curve. There's always a margin, always a residual, always something left unexplained. It's as if 3I, Atlas, is just outside the edge of symmetry, just irregular enough to avoid detection, just stable enough to challenge our models. That's not evidence of artifice, but it is evidence of difference. So what do we know? We know it spins slowly, smoothly, without precision, without chaos, with axis stability, with jet alignment, and with memory. We've never seen a comet do that. We've barely seen probes do that. That's why this matters. Because spin is the thing that never lies. Shape can deceive, brightness can fade, jets can fool. But spin remembers everything. Sometimes what we see in space is more about us than it is about the sky. We've all seen the image. 3 tails, 1 object, each shooting off in a different direction like spokes of a wheel. It's become a symbol of confusion, of anomaly, of awe. But what if we told you the image isn't real? Not in the way you think, because the sky doesn't give us photographs. It gives us photons, scattered, dim, fleeting, and we humanity turn that noise into meaning, with algorithms, with stacking, with choices, and every choice leaves something out. Let's start with how we see an object like 3i, Atlas. We don't point a telescope and snap a perfect cosmic selfie. We collect long exposures, some 30 seconds, some 5 minutes. We repeat that, sometimes for hours. Then we align those frames. We stack them to boost the signal, to suppress noise. But here's the trick. You have to choose what you align with. The background stars, the comet nucleus, a moving dust plume. Each choice gives you a different truth. Each truth erases a different reality. So imagine this. You stack on the stars. Great, everything in the sky appears fixed. But 3i, Atlas, is moving. So it smears. The jets blur. The coma flattens. Any short-lived features dissolve. Now try the opposite. You stack on the comet's nucleus. The object sharpens. But now, the stars become streaks. And faint background jets? They elongate, bend, and form ghost tails that were never there in the sky. This isn't fraud. This is how astronomy works. But it means one thing we forget. Every image is a decision, and every decision filters reality. This becomes critical with objects like 3i, Atlas. Why? Because the features we're trying to understand, jets, tails, asymmetries, are subtle. They live at the edge of the signal. They dance between frames. They shift with each minute, each stack, each processing pass. And we've seen this before. In 2i, Borisov, faint secondary jets appeared in stacks, then vanished with new calibrations. With Oumuamua, a gentle push hinted at outgassing, but we saw no coma. The truth was always just beyond our most confident image. Now, look again at the triple tail photo. Thailand, November 2025. The image that went viral. 3 luminous lines, 3 vectors of mystery. But check the acquisition log. It's not one image. It's a stack. 50 frames, aligned to the central bright source, processed with background flattening. That third tail, the one pointing sunward, may not be a tail at all. It could be a reflection artifact, a stacking echo, a motion compression error, or dust illuminated unevenly and stretched by interpolation. And that changes everything, because if the image is a ghost, the story is too. Look at the brightness data. Some observatories reported increased jet activity post-perihelion, but the timing matched poor seeing conditions, low altitude tracking, dust on lenses, thermal shimmer. Is the brightening real, or is it a side effect of trying to see more than the data permits? Because when we expect to see activity, we tend to find it. Even if it's just noise shaped like hope, we must also consider our own visual bias. Comet tails are romantic, spectacular. They're what the public looks for, what press releases love. So when an image appears with an unexpected tail, it spreads. But when a paper says no statistically significant increase in brightness over background, it doesn't go viral. We are tuned, as humans, to value images. But the sky doesn't owe us clarity, and sometimes what we see is what we wanted to see. Now enter the AI. Modern telescopes often apply machine learning to image cleaning, to denoise, to upsample, to guess what's really there. We train the models on past comets, on known jets, on dust shapes, and then we apply that model to something new, something like 3I, Atlas. But what if 3I isn't a comet? What if its morphology breaks the model? The AI will still fill in gaps, still sharpen edges, still pull out curves that resemble past data. And we, trusting the tools, may declare, look, a new tail. But it's not a tail. It's a prediction rendered as a photo. That's not astronomy. That's an illusion with good intentions. Now, let's not fall too far into doubt. There are real features in the data. The anti-tail, supported by geometry and light-scattering models. The sunward plume, possibly real if supported by Doppler spectra. The brightness, stability, verified by independent observatories. But the point isn't what's fake, it's that we don't know yet, and we won't until we build data pipelines that audit themselves. That includes frame metadata, publish calibration steps. That shows us not just the image, but the making of the image. That's how science earns trust. That's how anomaly becomes truth or disappears with dignity. Now, imagine this. You're standing in the control room of a deep sky observatory. It's 3 a.m. You've just processed the latest stack of 3I. Atlas. You see something strange. A spike. A curl. A phantom tail. Do you believe it? Or do you doubt yourself? Do you go public or wait for more frames? That moment, that pause is the most sacred thing in astronomy. Because in that breath, you choose between sensation and science. And the sky waits silently, either way. In the end, we are not just trying to see 3I, Atlas. We are trying to see ourselves. What do we filter out? What do we emphasize? What do we let go of too quickly? The stack is just a mirror of our bias, our hope, our fear of missing something extraordinary. But if 3I, Atlas, is truly extraordinary, it will outlast the artifact. It will show itself again, in different filters, different frames, different nights. And when enough seeing converges, the false fades, the real remains. So what do the images not show? They don't show certainty. They don't show motive. They don't show whether the light came from design or accident. They only show what we're willing to see and what we're afraid to lose. Sometimes that's enough. Sometimes that's a warning. There are silences in space louder than explosions. We waited for it. Not the light, not the dust, the sound. Not the sound you hear with your ears, of course, but the hiss of hydrogen, the whisper of OH masers, the ping of radar bouncing off ice. We aimed arrays, we booked radio time. We tuned instruments to 1,420 megahertzes and waited, but nothing came back. No burst, no echo, just background, quiet. This is where the paradox begins, because 3I, Atlas, is active. We see jets, we see acceleration, we see movement that defies gravity alone. But in the radio spectrum, silence. Meerkat gave us that one line, 08, 18 centimeters, a smoking gun for water outgassing. But beyond that, nothing. No complex spectra, no repeating chirps, no modulated signals, not even a faint irregularity suggesting internal processes. Just the hum of deep space. We expect comets to whisper, in water lines, in CO bands, in thermal bursts, when ice sublimes violently. But 3I gave us absence, a void in signal space. It's not just that we didn't detect anything, it's what all models should have. The energy is there, the heating happened, the jets are real, so where are the emissions? Where are the leftovers? The passive noise of being alive? Let's break this down. When a comet ejects dust and gas, it does so chaotically. Not just in one vent, but in bursts, in directions, in tiny avalanches of carbon monoxide, water vapor, and even ammonia. Each of these has a radio signature. Some are faint, some like water are bold, but in 3I, those harmonics never appeared. Even when we looked, even when we aligned antennae across hemispheres, even when we stacked the radio data like we stack images, we pulled the signal from the noise and found more noise. Pure, cosmic noise. Nothing that deviates. Nothing that hints at structure. This isn't the absence of activity. This is an activity without a footprint, like walking through snow and leaving no prints. It's unsettling, because it's unnatural. Now, consider radar. Goldstone tracked the object briefly. sent a narrow beam, hoping to bounce it back. Comets scatter radar, rough ice, irregular shapes, rotating bodies. All of them return a signature, even if weak. But 3i, nothing. No clear echo, no surface glint. No chirp that says, this is my shape, this is my spin. Just a deadline. A null return. Like pointing a radar at fog, or at something not made to reflect. You might think, maybe it's small, but it's not. The brightness, the dust plume, the jet size, they all suggest something at least 600 meters across. A mass big enough to throw detectable echoes. A surface chaotic enough to scatter, but we didn't see that, and the silence says more than noise ever could. Let's talk theory. If 3i, Atlas, is natural and made of ice and rock, then something's off with its surface composition. Maybe it's unusually porous. Maybe it's coated in fine carbon that absorbs the signal. Maybe it's so fluffy that radar dissipates into it like a sponge. But even those materials return something. A smear, a pulse, a delayed echo. This wasn't that. This was absence. No delay. No return. No whisper. Now consider the other theory. If 3i is not natural, if it's engineered, built, designed, then maybe the silence is the point. A stealth exterior, materials that scatter radar like black foam, surfaces shaped to avoid Doppler return. Not proof, not confirmation, but suspicion magnified by quiet. Because nature is rarely perfect, and this silence feels too clean. But even if we don't invoke alien design, even if we hold fast to natural explanations, the mystery persists, because the silence isn't passive, it's performative. Everything about 3i, Atlas, screams for attention, a triple tail, a sunward plume, non-gravitational motion. But the frequencies we trust to reveal truth? Dead. There's a philosophical weight to that. In science, we are trained to seek a signal, to find the thing that rises from the noise, to validate by detection. But absence is a kind of detection. It forces us to account for the unaccounted, to explain why, when we listened, the sky did not respond. And that breaks the comfort of our equations. So we check again. We reprocess. We recalibrate. We rerun the Meerkat logs. We comb through Alma's passive sweeps. We compare with Vera Rubin's temporal alignments. And still, nothing. No sign of embedded code. No thermally driven pulse. No statistical anomaly in band intensity. Only what's expected. Only what background models already predict. Imagine you're in that observatory, eyes on the spectral graph, watching that flat line stretch on. You want to see something, even a twitch, even a ghost harmonic. But the graph stays flat, as if it's waiting for you to give up, as if whatever's out there knows how not to speak. And now, we wonder, what if this is the signal? What if the absence is designed to test our patience, to force our assumptions, to make us confront the possibility that the loudest thing in the universe is silence? 3i. Atlas didn't need to explode. It didn't need to blink or blink back. It didn't need to shout, "I'm here." It just needed to keep moving, keep jetting, keep not speaking. Because that's what terrifies us. Not what we hear, but what refuses to make a sound. The silence might be a language we don't understand. We stared at the graphs for weeks. The noise floor held steady. The OH line? Yes, confirmed. But beyond that, every other frequency we tuned to came back flat. No Morse code, no pulse train, no narrowing band of encryption. But what if we're wrong about what to expect? We've always imagined the message would be loud. Radio, microwave, some deliberate burst of energy saying, "Look, listen, hear." But silence can hide something more sophisticated, something designed not to be heard, at least not with tools like these. Because not all communication is electromagnetic. Let's ask the uncomfortable question. What if 3i, Atlas, is sending something just not in any way we're equipped to receive? Not because it's hiding, but because it was never speaking in our direction. Or worse, because it's using a medium we haven't mastered yet. Imagine this. A probe traveling across stellar distances wouldn't waste time broadcasting in every direction. It would be tight, laser-focused, selective, or it wouldn't use light at all. Some scientists have floated the idea of quantum communication in deep space. Why? Because photons scatter, signals degrade, and time dilates. But quantum entanglement, that stays linked, no matter the distance. Spooky action at a distance, Einstein called it. But to a civilization with mastery over quantum information, it might just be how you say hello. No latency, no leakage, no need for power-hungry transmitters. Just a change in spin, or phase, or polarization, something that snaps into place instantly, but only if you're holding the other end. We're not. We have no receiver, no matched pair, no idea what particle basis they'd even use. If 3i Atlas is using a quantum key to handshake with something, we wouldn't hear it. We wouldn't even know it happened. And maybe that's the point. Now, widen the lens. What if the signal is optical, but not visible? We've scanned in infrared. We've watched in ultraviolet. But there are windows we barely explore. Terahertz, far IR, soft gamma flickers that could be tightly modulated. Not because we're ignorant, but because our instruments are tuned for natural phenomena, not artificial intention. We seek spectra that match chemistry, not ones that carry patterns. So when we see a faint pulse in infrared, we say, that's thermal variation. We don't say, that's data. There's another layer. What if it's using a carrier we don't even recognize as a carrier? Dark photons, axions, hypothetical particles that don't interact with ordinary matter the way light does. Some of these candidates have been proposed as explanations for dark matter. Elusive, weakly interacting, barely traceable. But if a civilization found a way to modulate them, they could send messages through entire galaxies without attenuation. Total stealth, total reach, zero interference. We wouldn't just miss the message, we wouldn't even know it exists. And then there's compression. If a probe wanted to store a message for retrieval later, it could compress a century of data into a single byte, encoded not in sound but in structure, in the alignment of its jets, in the interval between emissions, in the ratio of CO2 to dust grain size. What if the message is the pattern, not in signal, but in behavior? You've seen fireflies blink, but what if their pattern is code? Now imagine 3i, Atlas, jetting in a fixed direction, not processing, maintaining a precise outgassing orientation, despite tumbling dynamics. It's not chaotic, it's measured. Could that be information? There's precedent on Earth. Bracewell probes, first proposed in 1960. Autonomous interstellar messengers sent to wait, observe, and signal only when conditions are right. They don't need to talk all the time. They don't need to explain. They just need to behave in ways that trigger recognition. That's how you hide intelligence in plain sight. But there's a darker possibility. What if 3i, Atlas isn't signaling us, but listening? What if it's a passive collector? No beams, no transmissions, just a memory core, logging everything from our radio noise to our spectral emissions to our curiosity. Maybe it just wanted to know, how do the apes react to a mystery? This leads us to motive. What kind of intelligence builds a craft that doesn't shout, that doesn't leave a trail, that doesn't care if it's seen? One that isn't here to be found, or one that was found a long time ago but didn't respond because it wasn't time yet. You're starting to feel it, aren't you? That twist in your chest, the creeping sense that this visitor might not be a message, but a mirror. We keep asking, what is it saying? But maybe the better question is, what are we revealing? By trying to listen, we pointed antennas, we stacked signals, we ran Fourier transforms into the thousands of bins. Nothing. But maybe, in trying so hard to decode silence, we became the message. Observed, catalogued, stored. There's a final, haunting scenario. What if it did send something, and we already absorbed it? A neutrino burst, a gravity ripple, a quantum flip that registered on no known detector, but nudged something just enough to seed a question in a telescope schedule, in a YouTube thumbnail, in a whisper between scientists. Not a transmission, but a trigger. Because maybe communication isn't about language. Maybe it's about influence. You don't tell them. You make them wonder. You make them look. You make them change course. 3. Atlas may never blink. It may never reply. It may never curve or slow. But it already did something. It made us ask, what if silence isn't silence? What if the universe has been talking this whole time, but only to those willing to feel confused long enough to understand? The data is cold, but the debate? That's on fire. We'd like to imagine science as dispassionate, as if telescopes strip away ego, as if the people behind them are purely logical, immune to tension, pride, or fear. But 3i, Atlas, didn't just fracture models, it fractured the people reading them. It began quietly. An observation here, a telescope booking there, a Slack message passed in lowercase caution. Have you seen the OH line? Still jetting post-perihelion. Tail orientation. Looks wrong. And then, silence. Not because no one cared, but because everyone cared too much. Because the moment a comet stops behaving like a comet, the people who spent years studying comet physics suddenly feel something deeper than scientific curiosity. They feel threatened. At NASA's Goddard Space Flight Center, a team posted their preliminary models and then pulled them down 72 hours later. The reason? They were technically correct, one team member admitted anonymously. But it made it look like we were leaning into the non-natural narrative. We didn't want to fuel the fire. Over at the University of Tokyo, another group published a brief, arguing that the persistent jet direction could be explained by an elongated nucleus with symmetrical venting. But even that came with a footnote. This would require an unprecedented level of axial stability, which, in plain English, means we've never seen anything like this. Meanwhile, Harvard, you already know the name. Avi Loeb, the physicist who once stood at the edge of mainstream astronomy and asked, what if Oumuamua wasn't just a rock? To some, Loeb is a maverick. To others, he's a menace. And so, when he published a short op-ed suggesting that 3i, Atlas, might represent a continuation of anomalous interstellar visitors, the backlash was swift. Not from the public, but from his peers. One researcher tweeted, Loeb is once again trading credibility for headlines. Another wrote, more diplomatically, extraordinary claims require extraordinary discipline, not just evidence. But here's the uncomfortable truth. Most astronomers agree that something is strange. They just disagree on how loudly to say it. At the European Southern Observatory in Chile, teams have been collecting near-infrared profiles of 3i, Atlas, since before perihelion. One of their researchers summarized the internal mood like this. We're walking a tightrope. You don't want to underplay the data, but you also don't want your name in a paper that later becomes a punchline. It's not that scientists aren't brave. It's that the system punishes risk. A paper that says unknown behavior gets buried. A paper that hints at artificial origin gets media attention. And professional isolation. So most teams hedge. They write, further study required, possibly non-standard dynamics, unexplained residuals. They know what they've seen. But they've also seen what happened to others who spoke too soon. Now, look to the back channels. Discord groups, private Slack channels, peer review loops with redacted names not for objectivity, but protection. One peer reviewer rejected a submission because it implicitly encouraged exotic explanations. Another reviewer flagged a graph and wrote, be careful, this looks like intent. Intent. In a light curve. Let's be clear. There is no grand conspiracy. There's no silencing campaign. But there is a culture. A code, and that code says, do not blink first. It wasn't always this way. In the early days of SETI, curiosity reigned. In 1967, when Jocelyn Bell Burnell saw the first repeating radio pulses, the team literally labelled the source LGM1, Little Green Men, and yet they still published. They let the data speak. Today, you'd get laughed out of the tenure track for doing the same, and yet something is shifting. Among younger scientists, there's a rising hunger to break the taboo. A generation raised on Oumuamua, James Webb, and exoplanet atmospheres knows the universe isn't what we thought. They've seen models shatter. They've seen silence stretch. They've seen interstellar objects become normal. And they're asking, If everything is evolving, why are we still policing questions? One astrophysics PhD student put it this way: "We're told to trust the process, but what if the process can't absorb what's coming?" Another whispered, "I've run the simulations. The non-gravitational acceleration doesn't make sense, but I won't say it in my thesis. I can't afford to." It's easy to dismiss all this as noise, but when noise is this uniform, this carefully trimmed, you start to see the shape of the silence, and it looks like fear. Peer review was built to protect the truth, but it also protects consensus, and consensus is brittle. One good dataset can break it. One outlier can force it to bend. That's what 3i Atlas is doing, not just to our models, but to us, to the humans in the labs, in the domes, in the Zoom calls at 3 a.m., trying to make sense of a jet that doesn't precess. The most honest reaction we've heard? A soft-spoken astronomer in Spain who said, "We don't know, and we don't like not knowing." So here we are, a comet that isn't fading, a jet that doesn't wobble, a trajectory that defies tradition, and a field brilliant, proud, careful, struggling to find the courage to say, "This is not what we expected." In the coming weeks, we'll see new papers, new models, new stacked images, and perhaps a new tone. But for now, science isn't just data, it's people, and people are afraid, not of aliens, but of being the first to say what the data might mean. Reddit thinks it's a probe. TikTok says it's the end. YouTube, somewhere between. It didn't take long. The moment those triple-tail images hit the internet, Thailand, Japan, and Chile's telescope feed was already halfway to meme status. Threads ignited. Comments spiraled. The forums flared with words that haven't seen sunlight in years. Bracewell probe, doomsday harbinger, Nibiru confirmed. People weren't waiting for astronomers to explain. They were already explaining it to each other, with edits, with AI voiceovers, with 60-second cuts that mashed solar physics into ancient prophecy and back again. One video stitched 3i Atlas into Mayan glyphs. Another compared its trajectory to Revelation. A TikTok with 2 million views simply said, "It's not a comet, it's a countdown. No evidence, no source. Just the sound of a ticking clock and a slow zoom on a glowing streak. This is what science lives in now. Not the silence of ivory towers, but the roar of shared feeds. Every frame NASA posts becomes raw material for speculation. Every diagram becomes a springboard for drama. And every unanswered question, especially one shaped like 3i Atlas, becomes an invitation to believe and to fear. Even the name became fuel. 3i, some claimed, stood for Third Incursion. Atlas, Alien Transmission Listening and Surveillance. A backronym, born not of mission statements but of collective paranoia. It wasn't all nonsense. Some users pointed to the anti-tail geometry, the persistent outgassing, and the unbroken nucleus. They quoted real data, but wrapped that data in layers of suspicion. Why isn't NASA covering this more? What are they not showing us? If it's natural, why is it still alive? One Reddit thread went viral for simply asking, "What if it's parked?" The top comment, "Then we're already too late. This isn't new. We've seen it before. Oumuamua sparked it. Borisov found it. 3i Atlas just detonated it. Because this time, the images aren't fuzzy. They're beautiful and terrifying. There's something profoundly different about seeing a triple jet. Each tail crisp, each pointing in a direction that logic can't explain, especially when that image arrives not through a telescope sight, but as a YouTube thumbnail glowing on your phone at 2 a.m. For most people, space isn't about data, it's about metaphor. Comets are omens, visitors, warnings, and when one refuses to fade after the sun, glows brighter when it should be dying, spins without wobbling, and throws out a jet that doesn't process well, then it stops being just science. It becomes a story, and everyone wants to be part of the story. There are Discord servers now tracking nothing but 3i Atlas. One pinned message reads, "This is it. We won't get another shot." Another says, "The elites know. That's why the observatories keep going dark." Videos claiming the Vatican telescope has data on 3i rack up hundreds of thousands of views. A viral tweet read, Notice how no one talks about Apophis anymore? That's because this is the real threat. This isn't just misinformation. It's a cultural reaction, a pressure valve. Because underneath the memes and doomsday edits is something raw, people trying to make sense of a universe that no longer feels predictable. Climate, war, AI, viruses, governments are collapsing, and billionaires are building rockets. Then something from deep space bends a few rules, and suddenly it all connects, or seems to. If 3I, Atlas is just a comet, it feels like a letdown. If it's more, then maybe all the chaos means something. Maybe the noise has a pattern. This is the emotional math that science rarely gets to control. It can publish the OH 18 cm line. It can show the lack of a comma, but it can't stop a 20-year-old in Brazil from cutting those findings into a TikTok that ends with "wake up." They're here. And that's the point. Space no longer belongs to scientists alone. It belongs to the feeds, to the comment sections, to the collective dream space of billions who are staring at the same sky and wondering what it wants. Some wonder with fear, some with awe, some with profit. Several experts have already offered to interpret 3I, Atlas, for $99 a session. Others claim they can help you align with the comet's energy. One influencer sells interstellar protection stones, which, for $45, promise to block comet radiation. This is the price of mystery. It invites belief. And belief, once unlocked, rarely listens. Even mainstream media is dipping in. Headlines flirt with drama. Alien object, strange visitor defies science. Articles include real astronomers, but always next to a wild quote from someone who thinks 3I is a ship. The contrast sells, clickbait wins, and meanwhile, the real teams, those staring at spreadsheets, spectra, and stacked frames, fight a losing battle for nuance. Their answers are cautious, probabilistic, more data needed, cannot rule out. But TikTok doesn't wait for peer review, YouTube doesn't pause for error bars, and Reddit's upvote algorithm doesn't reward humility. So the myth grows, so does the unease. Because deep down, we know science moves slowly, and this thing, this silent, glowing, logic-breaking traveler is moving fast. It doesn't blink, it doesn't explain, and it doesn't care how many theories we have. It just keeps going, and we keep watching, because what the public really thinks isn't just alien or doom. It's this. Please, let it be something, because something would mean we're not alone. Something would mean we're not crazy. Something would mean all the chaos has a center. And right now, that center is 3I, Atlas, or whatever it's pretending to be. It's from out there. It's passing through. And nothing we know explains what it's doing. Start there. Strip away the metaphors, the fear, the headlines, the poetry, the noise. Remove the edits, the comment threads, the speculation. What are we left with? This. A point of light, moving too fast to be from here, glowing in ways it shouldn't, behaving in ways no model can reconcile. That is the only thing we know. We call it 3I, Atlas, but that's just a label shorthand for its third known interstellar origin and its discoverer's sky survey. What it is, we don't know, but where it came from, we can trace. It entered the solar system on a trajectory no bound object could follow, not from above, not from behind, but nearly sideways, cutting across the plane of the planets like a cosmic T-bone. Its eccentricity? Greater than 1. Its speed? Too high to loop back. Its orbit? Hyperbolic. Inbound from no star we can name, outbound toward no system we can track. That alone is a statement, a rare one. It is not of us, and that fact, simple, clean, unignorable, should be a foundation, a calm place to stand. But even that certainty doesn't stay still, because the moment we try to map what 3I Atlas does next, the confidence cracks. We expected it to slow after perihelion. It didn't. We expected the coma to dissipate. It didn't form. We expected a dust trail. None. We expected jet precession. The jet stayed fixed. We expected it to fracture under solar heat. It stayed whole. Every prediction failed. Not catastrophically, but subtly, consistently. It moved as if guided not by randomness or decay, but by some hidden internal rule, a script we haven't read. That's not how nature usually works. Comets, real ones, are messy. Their spin wobbles, their jets flare and shift, their bodies crumble. But 3i, Atlas, it's efficient. Too efficient. Even its brightness profile is strange. Standard thermal models say it should have dimmed by now, but it didn't just resist fading. It brightened post-perihelion, brightened after surviving the most intense thermal assault the sun can deliver. And yet, the nucleus stayed steady. No fragmentation signatures, no cascade debris. Just that same tight profile. A pinpoint, a core, solid, unyielding. We try to explain it in natural terms. CO2 jets, unusual shape, low rotation, surface layering, sublimation, insulation. Each explanation buys us time, but not clarity, because for every hypothesis we test, another crack opens. The OH 18cm radio line says there's water chemistry, but there's no visible water. The jet direction suggests stable thrust, but the spin doesn't match. The anti-tail geometry implies large dust sheets, but we can't detect any backscatter. It's as if the object obeys only the parts of physics it chooses. And that's uncomfortable, not because it suggests something supernatural, but because it suggests something we don't yet understand. In science, we live for that moment, the edge, the place where the known breaks into the unknown, but we don't often live with it day after day, data after data, as the models fail and the object keeps doing what it does, which, for now, is keep going. It crosses our system like a stone skipping across a pond. One touch, then gone. No loop, no return, no orbit to settle into, just a flyby. And during that flyby, we've thrown everything we have at it. Meerkat, Vera Rubin, ALMA, LCO, all the big names, all the global eyes. And still, the best we can say is this. It's not from here. It's doing something strange. And it will leave before we understand it. There's a humility in that. We don't like it, of course. We want conclusions. We want answers that snap into place, preferably before the next news cycle. But this isn't a tweet. It's a visitor. And visitors don't owe us an explanation. Sometimes they just pass through. That's what we have to live with now. Not the silence, but the unknowing, the stubborn fact that for all our instruments, all our charts, all our simulations and thermal maps, we are watching something that refuses to be solved in real time, and it might never return. We can extrapolate its path. We can estimate how far it has come. But what we cannot do, what no telescope, no algorithm, no AI can do, is explain why it shines the way it does, why it moves without fragmenting, why it spins without chaos, and why it radiates just enough mystery to pull us in. That is the only thing we know. It came from somewhere else. It doesn't fit, and it's leaving soon. What will we say about it after it's gone? Will it be just another footnote in the catalogue? A curve on a JPL database? Or will it stay with us not as a solved object, but as a symbol of how much we still don't see? Because maybe that's what it really is. A mirror. A test. A chance to remember that even now, with all our data, all our confidence, all our equations, something can still appear in the sky that breaks the pattern. And that, maybe, is worth more than an answer. That, maybe, is the real point. Not to solve everything, but to be the kind of species that keeps looking anyway. Even when the data stings, even when the models break, even when all we're left with is a line in the sky and a question we can't yet answer. We watched it come. We watched it refuse to behave. We watched it survive what it shouldn't have. And now, well, watch it go. And that, whatever it means, is the only thing we know. It formed around another star. That's where we have to begin. Because if we take its path seriously, if we trace its angle, its velocity, its unbound trajectory, there is no other honest place to start. It came from somewhere else. And in that simple fact lives the first ghost of a story. Maybe it began like all small things do, in the cradle of a star-forming region, inside the luminous fog of a molecular cloud. Long before our sun was born, long before Earth had cooled, something collapsed in the dark. A slow-spinning disk, dust sticking to dust, ice clinging to rock. Shocks from nearby supernovae feed momentum into matter. Chemical gradients are forming. Heat drives off lighter gases, denser cores accreting. And somewhere in all that slow violence, a solid piece took shape. Not a planet, not quite a comet, something in between, a seed, not unusual in shape, maybe, but placed just oddly enough, just far enough from its parent star that it never found a proper home. Maybe it was a moon that never got captured. Maybe a planetesimal was ejected before it could join a system. Maybe it formed in isolation, a rogue fragment in a rogue system. Time passed. Millions of years, then billions, and still it wandered substellar, silent, unlit, cutting across voids we cannot name, slipping through gravity wells that tugged but never caught, until a particular path bent it toward a small yellow star on the edge of a quiet spiral arm. That star was ours. But the visitor, it had no allegiance. Its material makeup may carry the memory of that ancient origin, ratios of carbon, oxygen, and rare volatiles in patterns unlike what we see locally, an overabundance of CO2, a chemical fingerprint of its forgotten nursery. We see echoes of it in its current form, the way it resists fragmentation, the way its jets fire without rotation, the way its path arcs clean through the solar system without falling into it. It is not reacting the way our comets do, because it did not form the way our comets did. Our models are based on the architecture of this system, this Sunday, these planets, this dust. But 3i, Atlas, is older than all of that. It remembers a different environment, or maybe something more. Because some of the behaviors we see, the non-gravitational acceleration, the axis lock, the persistent jetting, have analogues not in nature, but in design. And if we let ourselves imagine, responsibly, quietly, with the humility science demands, we must at least consider that this object might not be entirely natural. Imagine a fragment of an ancient construct, a remnant, not active, not alive, but built, or once part of something built, a thermal shell for a larger system, a propulsion chamber, a casing for something long since decayed, not transmitting, just moving, still following orders baked into its shape. Could it have been part of an interstellar network, a defunct navigation relay, a discarded test, or something even older than machines as we understand them? We can't know, we likely never will, but even these questions matter because they reveal how little we truly grasp about the deep time of our galaxy. How many stars have come and gone before our sun even lit? How many civilizations might have emerged, sent something outward, and faded before we were microbes? Even if this object is purely natural, it's still a relic, a wanderer from an epoch long before us, a fragment of the galactic archive, carrying within it material and motion that predates every story we tell. That's not poetry, that's math. We can measure the age of the atoms, the time since their last major reprocessing. We can model the orbital dynamics that brought it here. We can see that its time inbound is measured not in years or centuries, but in eons. That's why we call this part the origin story, not because we know how it began, but because it reminds us that everything we see, everything we build, is part of a chain we only briefly touch. Right now, 3i, Atlas, is touching us, not literally, but gravitationally, observationally, psychologically. It appeared. It moved in ways we didn't expect, and it told us without speaking that we are not the center of understanding. We are one dot among many. We try to flatten that truth with models, spin states, energy equations, spectroscopy, and that's good. That's the work. That's the right kind of discipline. But we also have to leave space for what we don't yet understand. The orientation of its jets, the silence of its spectrum, the strange persistence of its shape. Even its arrival window, a razor-thin path that slipped between our detection thresholds and came into view only because someone decided to look now, not later. That's the thing about stories like this. They don't always end with a sentence. Sometimes they just leave you watching the sky, wondering. That's what origin means, in a universe like ours. Not an answer. A trajectory. And if you trace this one back far enough, it doesn't lead to Earth, or Mars, or Jupiter. It leads to before. Before this solar system, before this planet, before the words we're using now were ever invented. And still, it came. Still, it moves. It challenges Engis. That's the story. Not because it's complete, but because it's not. We solved nothing, but we mapped the questions. We are used to answers. In science, the loop feels familiar. Observe, model, predict, confirm. But 3i, Atlas has refused to close that loop. It gave us data, yes, but what it gave us more of was tension. Let's start with what we know. We know it came from outside. Its trajectory is hyperbolic and unbound, with an eccentricity far beyond what any solar system object should show. It is moving too fast, too steeply, to have originated from anything orbiting the Sunday. It is, unequivocally, interstellar. We know it is active. Post-perihelion, after its closest approach to the Sun, it should have faded, but instead, it brightened. We have multiple independent observations showing persistent outgassing, increased dust activity, and rising brightness precisely when models said the activity should cease. We know there are jets, likely CO2-driven. These jets appear stable. They do not precess, as one would expect from a rotating body with irregular venting. They seem aligned, intentional, sustained. We know that one of the jets forms an anti-tail, a tail pointing directly toward the Sun, which under classical models should only happen under specific geometric conditions involving dust plane alignment. And yet, here it is persisting, brighter, sharper than before. We know there is no visible coma, no wide halo of gas and dust as with traditional comets. It holds a sharp profile, concentrated, focused. We know that there is no fragmentation trail, no long dust tail streaming behind, no debris field, nothing that suggests the object has shed significant mass or broken apart during its approach or retreat. We know the object spins, but the jets do not change. This violates our simple expectations about rotational dynamics. Either the jets are not tied to rotation, or the rotation is axis-locked in a way that stabilizes output in a manner uncharacteristic of natural comets. We know, thanks to Meerkat, that there was a clear 08 18 cm radio detection, which implies the presence of water molecules H2O breaking into OH via solar UV radiation. That is chemistry, not rumor. That is a receipt. We know that our images can lie. The stacking process used in long-exposure astrophotography can create artifacts, false jets, ghost tails, and smearing. Some of the images we believed at first must now be revisited, recalibrated, and reinterpreted with caution. We know there has been no other signal, no radar echo, no EM burst beyond the OH line, no coherent pulse, no thermal signature indicative of machinery or transmission. Radio silence, profound, persistent, and real. We know the public has responded with wild speculation, aliens, probes, prophecies, but none of that is science. What matters is the measurable, and those measurements are strange enough without adding fantasy. That's what we've learned. But now we must turn to the more humbling list. What we haven't. We don't know its exact shape. The light curve gives us hints, but not certainties. Is it cigar-shaped, pancake-shaped, hollow, dense, asymmetrical? The answers depend on spin angle, reflectivity, and vent location, and those variables are not fully constrained. We don't know how its jets remain directionally stable. If it's spinning, they should wobble. If it's not, how are the vents regulated? What governs their orientation? We don't know why it didn't explode. Thermal models suggest that by the time it hit perihelion, the internal pressures should have exceeded tensile strength. It should have fractured, yet it didn't. We don't know what's inside. Our models for cometary structure, from porous rubble piles to differentiated layers, fail to predict this behavior. Is it solid? Is it venting from internal channels? Is there a pressurized core? We don't know where it came from. Yes, interstellar space. But from where, exactly? Which star? Which system? Which epoch? We have rough backward projections, but interstellar drag and gravitational perturbations over time make precise tracing impossible. We don't know how old it is. Is this object from 100 million years ago? A billion? Longer? The isotopic composition might tell us someday, but for now, we have guesses. We don't know why the brightness curve rose after perihelion. That's not how solar heating normally works. Something changed, but we can't say what. We don't know what it wants, because it doesn't want anything. That's the default. But if its behavior mimics design, we can't help but question our assumptions. We don't know if it's alone. Are there others like it? Have we missed them? Will more come? Was this a fluke, or part of a larger population? We don't know what role Earth played, if any. Was this flyby incidental? Was the path gravitationally bent by outer planets? Or did this object target the ecliptic for a reason? And most of all, we don't know how to talk about what we don't know. Because that's the hardest part in science. Not the data, not the math, but the humility. Admitting that the questions now outnumber the answers we started with. That's not failure. That's growth. Because now we know what to watch for next time. Well, be faster in setting up OH-line observations. Well-run thermal models with broader parameter sweeps. Well, re-examine our assumptions about jet mechanics. Well, scrutinize light curves for axis lock. Well, simulate anti-tail formation under more edge case scenarios. Well, listen better. Well, question harder. Well, expect the strange. Because that's what this object really gave us, not conclusions, but coordinates for curiosity. A map of questions. Each one is a direction our science has yet to go. That is the quiet triumph here. Not the headlines, not the drama, but the soft shift in posture from "we understand" to "we're learning." It's the moment when the lab coat leans back, folds their arms, and whispers, "That doesn't make sense." Yet, that's what we're standing in. A yet. A space where wonder is still allowed. Where science is not a fortress but a window. And through that window, an object just passed. Still moving. Still whole. And we are left with no answers. But with better questions, whatever happens next, we saw it. There's a moment every observer knows. It has nothing to do with equipment. The dome opens. The hum of the motor fades into long, patient quiet. Your eyes adjust to the black-on-black geometry of the sky. And then there it is. A dim smudge you've chased for weeks finally drifts into frame. It isn't bright. It isn't noble. It's a grain of ash drifting through the cold. But it does something only the sky can do. It rearranges you. We watched 3i. Atlas first through noise, then through knowledge. A dot became a curve became motion. Motion became a visitor became a question, then the question became several. Then a field of unresolved tension. But through all of that, something remained. We didn't watch because we were afraid. We watched because we remembered what not watching once cost us. In 1908, we didn't see Tunguska coming. In 1983, we almost missed IRAS, Araki Olcott. In 2017, Oumuamua slipped through like a whisper. And now, in 2025, 3i, Atlas, offered us something rare. Not just a sighting, but a second chance. To ask better, to look longer, to hesitate less. We watched as its brightness rose when it should have dimmed. We watched as jets remained fixed when they should have wobbled. We watched a tail split into geometry that our models couldn't fold. We watched as thermal predictions bent and then broke. We watched no debris trail form, no fragments fall behind, no coma swell. We watched spin without precession, acceleration without coma, chemistry without steam, trajectory without origin. We watched the silence too. The absence of a signal, the stillness between pulses, the quiet frame when the time-lapse ended, and there was nothing new. And still we watched, because watching is an act of care, of curiosity, of reverence. We did not build telescopes because we were paranoid. We built them because the sky is the only cathedral big enough to fit our questions. And 3i, Atlas, became the sermon we didn't expect. For 2 years, it approached. Then for 2 weeks, it vanished hidden behind the sun, invisible to every eye, untouched by any beam. And when it emerged, the object we thought we knew wasn't the same. Still intact, still active, still accelerating, still jetting. And so, we did the only thing we could do. We kept watching, we stacked frames, we ran simulations, we hunted O8 lines, we reprocessed dust curves, we adjusted filters, we built mirrors, we held our breath, we sat in silence. Not because we had nothing to say, but because sometimes silence is the only way to hold wonder without dropping it. And while we watched, something else happened. Memory began to stack. Not just data, but meaning. This wasn't just an object anymore. It was a mirror. It reflected not just light, but also posture. How do we stand in front of the unknown? Do we rush to declare? Do we bend it to our models? Do we name too fast? Or do we let the unknown stay unknown? For once, we chose restraint. We let the question breathe, and in doing so, We remembered that science is not about certainty, it's about the ethics of attention. To point a dish, not just to detect, but to respect. To follow a dot, not just for answers, but for alignment. To build time into our seeing. Because, in watching, we also changed. We became better listeners, calmer questioners, more patient observers. The legacy of 3i, Atlas, may not be new physics. It may not be proof of life or craft or engineering. It may not alter textbooks, but it has already altered us. It forced us to hold two truths at once: that nature is stranger than we expected and still within reach. That silence can mean absence or presence in another form. That nothing happened is not the same as nothing mattered. We often think of space as indifferent, but in watching this object, we realized it is not indifference. It is an invitation, the kind that doesn't shout, that doesn't repeat, that doesn't care if you show up or not. But if you do, if you open the dome, if you focus the lens, if you sit through the noise, then sometimes, just sometimes, the universe lets you see a thing that rearranges you. And that's what this was. Not a breakthrough, not a revelation, but a rearrangement. A slow, quiet reordering of our sense of what's possible, what's stable, what's visible, and what's worth staying awake for. We didn't prove anything, but we stayed present, and maybe that's enough. To be the species that notices, that writes it down, that tells the story even if we don't yet know how it ends. We watched, and it watched back, not with eyes, but with its presence, with its persistence, with the long, clean line it carved across our sky. Whatever happens next, if it fragments, if it fades, if it vanishes beyond the heliopause, we can say one thing with full honesty. We saw it, not perfectly, but faithfully. Not because we had to, but because we could. Because sometimes the most important part of a mystery is showing up to witness it. That is our legacy here. Not a solved problem, but a seen visitor and a shared silence.